Hey friends, let's talk about row operations and matrices for a little bit. I guess like this is a different approach. So let's think of it. I kind of have a progression here. So I want you to think of an equation as simply a statement of a fact, like what is true. Like so, for instance, like we have really easy equations, like x is 2. That is a fact in this world if I state it. You know, we can make more complex facts, something like 3x minus 4 is equal to 2. But if we state with an equal sign, we take this as a statement of fact. Nobody can argue it. So then as we progress forward, it says, we know that when we have two variables, like here I have x's and y's. So if I have two variables, I'm going to need two unique facts to determine the values of the unknowns, right? If I told you two facts that x was equal to 2 and x was equal to 2, that really doesn't descriptively tell you that if it was just by itself, right? We need two different, I guess we put that as like a separate question. If I just told you x was 2 and x was 2 and you didn't have any of this, you would never know what y is because you don't have two unique facts. So when you see an equation right now, think of it as a fact. Now from here on out, I'm going to tell us what these facts are. So we can see that when we manipulate facts, the facts that we have can be anything, and we can change facts in certain ways, and then they're still facts. So let's kind of keep these kind of guiding principles in mind. And this is what we notice will be on your notes. So in this world that I've created right now, I'm going to kind of say like we have this system of equations over here, and then just because we're aware and we know and I'm telling us, the way that I set this system up, I want x to equal 2 and y to equal negative 4. So what we're going to do today is we're just going to look at how we can manipulate facts and say that they're still facts. So just to like prove that this is true, like if we look at this equation here, just for, we'll call it number 1, let's say, 2 times 2 is 4, right? So we have 4, and then 4 times negative 4 is negative 16. So that definitely equals negative 12, right? You see this as a statement of fact. This is the same fact, just written in a different way. So if we look at equation number 2 then, 1/2 of x would just be 1, and then 3/4 of y would be negative 3, which is why we get negative 2. All right, so what I'm gonna be doing here is we have these facts. These are 100% known. So let's just go ahead and make sure that we understand that when we multiply facts, we add facts, or we multiply facts and then add them, that we are still, again, having what we need, two unique facts for a system of equations. So these are our two unique facts, right? And we see it in this form here. And then we're just making sure that we can see it in an easier way. So they're both facts, we agree on that. So what I can do then is if this is my system, right, we're gonna kind of look at it in two different ways. If we thought of it as a system of equations, and I like to put that there just to like separate the equal sides of the equation, because if I'm going to go manipulate things, I need to make sure to do it to both sides and every term. So it kind of helps me, again, keep organized on what the variables are and then what the right side is. So if we're going to solve a system, right, like if we were solving this system, we need to have two unique facts. So right now, we definitely have two unique facts, but I can change the system in a way that's beneficial to me without ever having to change the values of the variables, again, without changing the facts. So like, for instance, when I look at this first equation, everything's just like an even number. So I could reduce all of them by a factor of 1/2, right? So rather than using these two facts, which I'm just going to kind of label as number 1, let's just say A, because I have a number 1. So maybe I'm not using these two facts. What I could do is I want to create a new fact. I want to take equation number 1 and just multiply it by 1/2. So I'm going to do that all the way across, because if I do it to a fact, right, if I multiply a fact by a number, it should still remain a fact. So on the left side, we'd have x. I'm actually going to copy and paste a little bit just to save some time. So I'm still keeping two facts, but I'm changing the first one. So I'm going to cut that in half because I'm multiplying it by 1/2. 4 is now going to turn into a 2, and then negative 12 would turn into negative 6. And then again, this is still the same facts, just written in a different way. But we have to change that first one, right, because we cut everything in half. So if I multiply an entire fact by 1/2, right, it should have been now 2 minus 8 is negative 6. Negative 6. So we agree now that I still have two unique facts, right? 2 minus 8 is negative 6, and 1 minus 3 is negative 2. In other words, I still have two unique equations. Okay, well, let's keep going with that mentality then. Maybe these facts right here aren't the facts that I want to use to solve this equation. Maybe I want to come up with two new facts to solve this equation. And maybe I just don't like the fractions down there in my facts. So what I could do is write a brand new set of facts. But maybe I'm just going to change the second equation this time. Maybe I want to take that second equation and just multiply it by 4. because I want to get rid of all those fractions. So rather than having these numbers in my facts, let's just multiply everything by 4. So half times 4 would be 2. 3/4 times 4 would be 3. 4 times -2 is -8. Now let's make sure we do it to this fact, right? Because it's still a fact. 1 minus 3 is still definitely -2. Now if we multiplied everything by 4, isn't 4 minus 12 still equal to -8? Right? So when we're solving these equations here, which again, that's kind of where we started. We were trying to solve this system of equations as two statements of facts. I'm manipulating the facts through a lot of different things, right? We've seen us multiply an entire fact by a number, and I haven't changed anything about the system, right? Have you noticed that 2 minus 4 is still what's going on here for our variables? 2 and -4, 2 and -8 is where we get those numbers. So we definitely agree that multiplying facts by a number hasn't changed anything. Now the idea here though is if I'm solving a system of equations, why would I want two facts that use both of my unknowns? Wouldn't it be way nicer if like the original facts were just x is equal to 2 and y is equal to -4? If I started with those two facts, that'd be super easy to solve the system because that is the definition of the answer. So let's just change these facts again. I don't want them to have both letters in it, so let's continue to change the facts. Now what we saw here is we could multiply an entire fact by a number and add it to another fact. So here what I'm going to do is we still always need to have two facts to solve a system of equations. So I'm just going to recopy my system, and I'm just choosing, maybe I actually really like the second fact. It seems good to me, so I'm going to keep that second fact, but I'm going to have to change my first fact because, again, I always need two. So what should my new fact be? Well, maybe I'm going to take the second fact and multiply it by -1/2 and then add it to the original first fact that I had here, right? Because we said if I take a fact, multiply it by something, and then add it to another fact, it should still be a fact, right? We can see that if 4 is equal to 4, if I multiply, and let's say 6 is equal to 6, if I multiply this first fact by 3 and then add the second fact, isn't it still true, right? So I'm just going to come up with a new fact in that manner. So I'm going to kind of show some work here. So if I took the second fact and multiplied everything by -1/2, it would be -x minus 3/2 of y, and then that would equal 4. And then on this side, right, we would do it to that same number, right? So then 4 times -1/2 is -2, and then -1/2 of -12 is 6. And then half of -8 is 4. Now what we should do is take the original first fact and add them together, right? And that should give us a new fact, which again, as we see, should still be true. So if we add them together, we have 0 x's. We have, well, -1 and I don't want to get these numbers wrong. So -3/2, and then we add 2. That would be a half. Sorry, I'm struggling on that. And then if we add them over here, we get -2. And then what we see on this side, right, if we add that gets 0, -8 plus 6, and -6 plus 4. So if I just take that fact that we created and just write it up here, 0 x's plus 1/2 y is equal to -2. And then just making sure that we still see it's true over here with like when we substitute numbers, right? If we substituted -4, half of -4 should equal -2, right? So I'm just gonna like highlight that. This is now still two facts that we can use to solve the system of equations, right? But what I'm noticing now is like it's becoming easier to read two distinct facts. This no longer has any x's in it, and this is almost just a regular y. Now, one other thing that I kind of point that we're gonna see when we do matrices is I can reorder the facts, right? If I'm thinking about I just want to get y alone, and I want to get x alone. Maybe for me, I'm just going to erase a few things here. Maybe for me, it's easier to get x first, because that's what we traditionally do. So maybe instead of putting them in that order, I'm just going to switch them around. Right? Aren't they still facts if I switch them around? Right? Well, I can find y. I'm just going to erase this second fact. Well, not erase it, but I'm going to take that second fact and multiply it by 2. And I want that to be my new second fact. Because if I do that, which I'm just going to do above here, 0 times 2 is still 0, but 2 times 1/2 is now 1. Then I have to multiply that by 2 as well. And I have to multiply all my facts by 2. So this would just turn into -4 is still equal to -4. Right, but do you see now that I've isolated this, I know what y is explicitly. So what I could do now is let's change this fact so that y isn't in it, so I could just get x alone. And then I know 2 distinct facts about x and y. So what I could do now is, again, I'm going to kind of copy this table. These are still the 2 facts that I have. And I'm going to get rid of that first fact. But how am I going to rewrite it? I need to tell you how I'm going to rewrite it. So the way that I'm going to make this new fact is I'm going to take the old fact number 2. I'm going to multiply it by -3, because then I can add it to the original first fact and get a new fact. So I'll show my work below. So if I take the original fact and multiply every number in it by -3, notice how it's still true. I think one of my negatives forgot to transfer, sorry. And then I can add it to the original first fact, which I'm just going to rewrite in black. And then again, the original first fact over on top was 4 minus 12 is equal to -8. Now, this new first fact is still true, so I said I was going to add them together. So I have 2x, no y's, should equal 4. And then over here, see how the 12s would cancel? And then 12 minus 8 is 4. So that's definitely a true fact now. 2x plus 0y is equal to 4. And then over here, we do have that 4 is equal to 4. Now, let's do one more thing. Let's create one more new fact. Let's take that original first fact and multiply it by 1/2. I'm just going to do it up here in my work. So 1/2 of 2, that's 1. 1/2 of 0, still 0. 1/2 of 4, though, let's just call that 2. And then we'll cut both of these sides in half. So 1/2 of 4 is 2 and 2. So what I hope you can see that we just did is we solved the system, right? We know that x is 2 and y is -4. And this is what I want you to think about is all we're doing when we're using row operations on matrices is we're just rearranging facts. We're starting with some really weird facts that kind of suck. And notice how I tried to force in some ideas of a matrix. Do you see how when I put this little line there, that to me I said was help separating my left and right side of my equations. Well, you can see how that definitely translates over to the idea of a augmented matrix. Even with my dotted line, that's an augmented matrix there. So I want you to think about we were doing something on this side, and we're just keeping track of what we did. So that's why we were always doing it to both sides. So all we were doing was starting with facts and just rearranging them, right? 4 minus 16 is still -12. If we cut that in half, 2 minus 8 is -6. So we were just manipulating the facts in a way that was a lot easier to read them. So we could just isolate one fact about x is equal to 2, and one fact about y is equal to -4. So I hope this brings a little more clarity or maybe some intuition when it comes to doing your row operations with matrices.